Happy Wednesday, Lucy. So this is our maths lesson again for Wednesday. So this is your guided practice, so you can listen to me and then you complete your independent practice. Remember, you can watch the PowerPoint as many times as you can so you will fully understand what I'm saying to you. So Lucy, our warm-up today is to count in our threes. So let's get practicing together. We know 0 times 3 equals 0. 1 times 3 equals 3. 2 times 3 equals 6. I hope you're counting with me. 3 times 3 equals 9. 4 times 3 equals 12. 5 times 3 equals 15. 6 times 3 equals 18. 7 times 3 equals 21. 8 times 3 equals 24. 9 times 3 equals 27. 10 times 3 equals 30. 11 times 3 equals 33. And 12 times 3 equals 36. Now, why not have a go at counting just the answers and clapping at the same time? So 0, 3, 6, 9, 12, and so on. So today's learning objective is tenths on a place value grid. So our question is to write the decimal that is shown in each place value chart. So you can see it's represented differently this time. We haven't got 100 square, but we have a place value grid. So we have our ones and our tenths. And our tenths in this place value grid is our lowest value. So I have 0 ones and 1, 2, 3, 4 tenths. So my answer is 0.4. And we also know that's equivalent to how many tenths? 4 tenths. And even to show off a bit more, if it was on 100 square, it would be, yes, 40 equal little squares shaded out of 100 little squares that are equal parts. Or here, 4 equal rows or 4 equal columns shaded out of 10 equal rows or columns. Can you have a go now at this one and this one in your independent practice? Good luck. So this question is asking us to draw counters on the place value charts to represent each number. So what was the same as the last question was that we had a place value chart, and what's different is that the counters were already inside of the chart. So we need to draw them this time round. So I know here I've got 2, my decimal point, and my 1. And now it's time to kind of identify what is the value of those numbers. So 2 is in my ones column. I have my decimal point, and I know the 1 is in my tenths column. And that is my lowest value that we're looking at today. So if I'm going to draw counters, I know I have 2 ones. There is my decimal point, and I have 1 tenth. Now let's have a look at B, 1.2. Again, I have my ones, my decimal point, and my tenths. And the lowest value is, yes, the tenths. So I'm going to draw how many counters in my ones? 1, good girl. And how many tenths have I got? 2. Now, can you have a go at your independent practice? You'll just have to type in onto your answer sheet how many counters is required in the ones and the tenths column for each of these numbers. Good luck, Lucy. So we're just going to talk through this one together as guided practice. So our question is, Rosie is using this place value chart to make numbers. And we have our ones, and our smallest value that we are working with today is our tenths. So she uses all 8 counters each time. And so we've got to complete the sentences. So the smallest number possible is, I would make sure that I have 0 ones, and then use these as tenths. Because remember, I have to use the counters each time. So I would have 0.8 as my smallest possible number. Now, could you have a think? What would be the greatest number possible? Remember, if the tenths column is the smallest value that we are working today, where could the 8 counters possibly go? And what would be my number? Yes, I think you're probably thinking correctly. I would put my 8 counters in my ones, and I would create the biggest number with my 8 counters and create the number 8. Now, C is asking me to create a number between 3 and 4. So how many counters do you think I need in my ones column if I'm making a number between 3 and 4? You may want to think back to yesterday's lesson when we had the number line between 0 and 1 and our decimal numbers in between those in the equal parts. We had 0.1, 0.2, 0.3. Now it would be exactly the same if I have a number line between 3 and 4. So here is 3 and here would be 4. If I had 10 equal parts dividing the number in between, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, what could the decimals be? Yes, I could actually say that I'm going to have 3 ones here, and I could say it could be 3.1, could be 3.2, 3.3. Let's do 3.4, and that number would be between 3 and 4. Now, I wonder for D, what could the answer be? The closest possible number to 5 is. Now I know if I've got my number line here between 3 and 4, the closest possible number to 4, being a decimal, would be this number here. What do you think that number would be? If I know that this is 3.1, yes, it would be 3.9. So if I've got a number line and it was between 4 and 5, what do you think my closest number would be to 5? I've got 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9. That would be my number that is closest to 5. And you can see that on the number line, even with our different representation between 3 and 4, it'd be the same, but we've also increased by 1 whole. So again, we're going to speak through this one together, and it's just to show you variation with the types of questions that you would get, so we become fluent in this objective. So Tommy has made a number on a place value chart. Now it's really useful to know and to think about how many ones equal 10, Lucy? Well, we know that 10 lots of 1 equals 10. And then we think about, well, how many 10s make 100? Oh, it's 10 again. So I wonder how many 10s would equal 1. So let's have a look. We've got 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. And we know that when we have a fraction that is the numerator is the same as the denominator, it equals a whole. So actually, I could exchange all of those counters, 10/10, for 1 whole 1 counter. And then, how many counters do I have left over in my tenths place value column? Yes, I have 1, 2, 3. So the decimal that Tommy has represented in the place value chart is 1.3. Now, do you see how there we've got 10/10 equals 1 whole? So if I write that there, so 10/10 equals a whole. We know that when the numerator is the same as the denominator, it equals a whole. Just like we know that 10 lots of 1 equals 10, and 10 lots of 10 equals 100. Now it's saying we've answered A and then B. Can we draw counters to show how Tommy could have represented this differently? Oh yes, we've just done it. We could have one whole one in the place value column of the ones, and then our lowest value, our tenths, we can have the 3/10 counters, which gives me the decimal 1.3. Or, as an equivalent fraction, be 13 equal parts shaded out of 100. So thinking back to that 100 square grid. Now we've spoken about our method. Could you think of a different method that you might use, or did you find this one helpful? So we've got some guided practice here. I'm going to show you A, and then you're going to complete B independently. So our question asks us to complete the number sentences that match the place value charts. So again, I've got our place value grid with our ones and tenths of our lowest value that we are working with today. So I have 2 ones, decimal point, and 6/10. So I'm going to fill out this same sentence now. There are 2 ones and 6/10. So I then know that 2 ones add 6/10 equals 2 add 0.6 equals the decimal 2.6. I wonder now, would you be able to have a go at B? Good luck. And here again we have some more variation to help us practice this objective. So we're going to practice drawing counters to represent each of the numbers. And we're going to write it as a decimal once we've drawn the counters in. So A, it's telling me that there are 3 ones and 2/10. So I am going to draw 3 ones and 2/10. Now to help me, I might write the number underneath, so I know what my decimal will look like. So I have 3 ones, I have my decimal point, and I have 2/10. So the decimal that is being represented in the place value chart is 3.2. Again, that might look like as a fraction 32 hundredths, because we know that there would be 32 equal squares shaded in on our 100 square. Now, could you complete question B independently? Good luck. Again, we're going to speak through this one together, but I'm hoping now that you're starting to understand the learning objective. So, see if you can do some of these mentally. So we're going to match the written numbers to the place value charts. Our first one is 1/10. So I'm not looking for anything in my ones column because I'm looking at the smallest value that we're working with today, which is our tenths. So I'm looking for 0 ones and 1/10. Oh, there we go. I've got it right there. Did you get that one? Now here is a bit more tricky. I've got 21/10. Now I know that 10/10 equals 1 whole. And if I've got 20 of those, that would then equal 2 wholes. And then if I've got 2 whole ones and 1/10, can you see that on the place value grids? Yes, I can see it as well. We've got 2 ones and 1/10. Brilliant. Couldn't you see now, knowing what I've just told you, where is 12/10? You know that 10 lots of 0.1 gives you 1 whole. And then how many 0.1s or tenths would be left over? If you've got 10 making 1 whole, 10 add something equals 12. So how many tenths would you have? Good. I have 1 whole and 2/10 because I know, if I'm thinking using my number bonds, I know 10 add 2 equals 12. Good girl, Lucy. And then we can see at 10/10, we know that 10/10, 10 lots of 0.1 equals 1 whole. So I have 1 whole and no tenths. So this is our last slide, and we're going to speak through it again. So we've got our little character here, and we'll call him Alex. So Our question is 6 tenths added to 4 tenths makes 10 tenths, which is a whole. Saying how many other ways can you make a whole from tenths? So let's have a look first of all what Alex has said. He is telling me that 6 tenths, which is equivalent to 0.6, so 0 ones and 6 tenths plus 4 tenths. This is as a fraction, but then adding it as a decimal, 0.4. I'm thinking of my counters in my place value grid, give me 1 whole. Now, if we look at these numbers and we're thinking about our number bonds to 10, we know that 6 add 4 equals 10, but these are 10 times smaller, these numbers. So we're going to use our 0.6, add 0.4 equals 1. What other numbers do you know that equal 10? That you could make numbers 10 times smaller into a decimal to equal 1. Oh, I know one. I'll write it in blue. We could have 0.3 add, what would I add to 3 to get to 10? Yes, good girl. It would be 7. So I'm going to make that number 10 times smaller. So it would be 0.7. So I know, remembering again what I have told you, that 10 lots of 0.1 or 1/10 equals 1 whole. So 0.3 add 0.7 equals 1. Could you think of any other tenths that would be added together to equal a whole? Well done, Lucy.